And I am on the desktop now, and I'm thinking that you guys can see everything that I can see. So again, we have 0, 20, so 0 degrees, and I can just bring this over. That's our initial velocity, 20 degrees, hypothesis, interpolation. And so I can just make this bigger. And what you do here is you just select on one of these points, and we're going to add a trend line. So I selected on one of the points, and then I right-clicked. And your system might be a little bit different, but you figure that out. I'm going to add a trend line, and you'll see that it's linear. So the trend line really, the points that I put up there, they're hypothetical, and I want to make sure that I can display my chart as well as my R value. So you'll see an equation here. And I'm just pulling it over. I'm gonna highlight all of this. And I wanna make it bigger so you guys can see it. I'll go down to 48. That should be big enough. It's probably too big, but still. So we have y is equal to 0.0252 times x plus the y-intercept. And we have r squared here. This is equal to 0.99973. So we have our equation of our line here, which will allow us to predict what's going to happen. And that's really good. And so let me close this thing so we can see everything well. And so basically, if we put 10 in for this value here, and let me bring up my calculator. If I use this equation and I want to predict what's going to happen at 10, remember when we just looked at our graph, we said, well, at 10 degrees, pull this up, at 10 degrees right here, what's going to happen? Well, at 10 degrees, we see that it's going to be around 0.65. So we could see that visually. But if we just wanted to have a number, we can go ahead and say, okay, what's going to happen on the y-axis if we put in 10 degrees for the x? So I'm going to say clear that, 0.0252 times 10 degrees, all right, plus 0.3881. So we end up with 0.6401. So both of them give us predictions. We can actually generate a finer resolution with this prediction because we can put in 10.5. You know, we can do those things if you know these are good numbers. So that would be our prediction. Again, it's a hypothesis. It's nothing more than that at this point. So if you look at this equation is basically linear. And so right now we're going between 0 and 20 degrees. What if we go out to 25 degrees or 45 degrees or 90 degrees? So 90 degrees is where you're firing the ball straight up. So if we fire the ball straight up, we're expecting our x, which is y in this particular case, because this is our predicted displacement in the x direction, to be 0 displacement, or 0 meters. So if I place that number in there, let's go ahead and test it. So we're now looking at an angle of 90 degrees. I'm going to say 0.0252 times 90 degrees plus 0.3881. We now have a prediction of the ball landing at 2.67 meters away from the launch position. Guys, this is over 2.5 meters away. A meter is over 39 inches or over 3 feet. So we're saying that this thing is going to land almost 8 to 9 feet away. No, that's not what's happening. Okay, we know this, and we could just predict it. We're just throwing. Let's just imagine you throw a ball straight up. If you throw a ball straight up, it's going to come right down into your hand. But if it's not going to make any displacement in the x direction. So we came up with another hypothesis over here.